Hey, what's up, guys? My name is Christian Romero, and today my presentation is on the Mid-Atlantic Ridge, a geological marvel. Did you know that the Mid-Atlantic Ridge is so vast that if it were to be above water, it would rival the Andes in scale? It stretches across the Atlantic Ocean, acting as a boundary between four major tectonic plates. Today, I'll take you on a journey to explore this fascinating feature, its geological processes, ecosystems, and importance to science and society. Let's start with the basics. The Mid-Atlantic Ridge is the longest mountain range on Earth, but it's underwater, running right through the middle of the Atlantic Ocean. It's pretty cool, right? What's happening here is that the tectonic plates are moving apart. This is called a divergent boundary. As they separate, magma rises from below, cools, creates, and becomes new oceanic crust. This process is called seafloor spreading. One of the best known parts of the ridge is the James Ridge near Iceland. Hopefully I said that right. It's one of the few places where this massive underwater feature is visible above sea level. It's like getting a sneak peek at what usually is hidden beneath the waves. Now let's dive deeper, literally, into what makes the Mid-Atlantic Ridge so fascinating, which in this case would be the hydrothermal vents, also known as black smokers. These vents shoot out superheated water loaded with minerals like iron and sulfur. It's so extreme down there, pitch black, freezing water mixed with scalding hot vent emissions, and yet life thrives here. Isn't that pretty crazy? What's amazing is that instead of relying on sunlight, the organisms here use chemosynthesis to survive. That means that they get energy from chemicals in the water. You'll find tube worms, clams, and even bacteria that might give us clues about life in similar extreme environments, maybe even on other planets. The Mid-Atlantic Ridge isn't just about new crust. It's a living record on Earth's tectonic history. So here's how it works. As the plates move apart, magma fills a gap and cools, forming new ocean floor. Over time, the rocks on either side record their magnetic field, which actually flips every so often. It's like a natural timeline etched into the seafloor. But it's not just geology. This ridge plays a role in shaping ocean currents like the Gulf Stream, which affects climate and weather patterns all over the world. So what happens here just doesn't stay here, it impacts the planet. Scientists love the Mid-Atlantic Ridge because it's like a giant open book about Earth's processes. It's where we made some incredible discoveries, not just about geology, but also about life in extreme conditions. It's also sparked interest in mining because the vents produce minerals like copper and zinc. But here's the tricky part. How do we explore or extract resources without harming these unique ecosystems? It's a question we're still figuring out. Exploration here has been led by research vessels and submersibles like Alvin, as you see on the picture below, which have even made it possible to reach these extreme depths and uncover so much about this hidden world. To wrap it up, the Mid-Atlantic Ridge is a perfect example of how dynamic and interconnected our planet really is. It's not just about geology. This ridge is a source of new crust, a home to extraordinary life, and a hotspot for scientific discovery. It reminds us of how much of the ocean and the earth we still have to explore. So here's something to think about. Could the secrets of the Mid-Atlantic Ridge someday help us discover life beyond Earth? It's a big question, and that's what makes this topic so exciting. Here are the references used for my presentation.